Okay, so this is question 20. CDF is a quadrilateral. CD is A, so let's mark that on. DE is B. FC is A minus B. A minus B. Express FE in terms of A and B. Okay, so FE. So we're trying to go from here to here. So we can go around this way. So we can go from F to C to D to E. Okay, so let's just add these up. So 20A. We got A minus B plus A plus B will get us to E. And this is equal to negative B plus B cancel out. So this is just equal to 2A. Okay, 2A. Now, that was nice and easy. Let's look at the next part, where it gets a little bit harder. M is the midpoint of DE. Okay, so that and that are equal. X is the point on FM such that fx colon xm equals to n colon 1. So this is n, this is 1. So it like splits it into like a ratio, and fx is n and xm is 1. Now CXE is a straight line. So CXE is a straight line. Okay. Work out the value of n. Let's first find FM, because we know that the proportion lies along FM. Okay? So we're trying to go from F to M. So FM, let me do this down here, sorry. Actually, no, I'll keep here. So FM is equal to A minus B plus A. And we're only going halfway down DE. So we're adding B over 2. And this gets us 2A minus B over 2. Okay. Now, if we want to find what fx is, you know that fx is just n over n plus 1 of this. N over n plus 1 of 2a minus b over 2. Okay. And obviously, let's just do fm just for sake of xm. You know that 1 over n plus 1 times 2a minus b over 2 is equal to xm. Okay. Now we know that we want to find what n is. We know that CXE is a straight line. So let's find CX in terms of n. And let's find CE. Okay. And because they lie along the same line, we know that CX times a certain constant is going to be CE. Okay. And we know that CE will have no values of n in it. So we could just match up the coefficients to find the value of n. That might be a bit confusing, so I'll show you how we do it. So first, let's find what CE is. So CE is equal to negative bracket a minus b plus 2a, which is the same as b minus a plus 2a, and this is equal to b plus a. Okay? B plus a. Now, we know that CX is going to be a fraction of b plus a, because they lie along the same line. I'm just going to call this fraction k. So CX is equal to kb plus a, and this is equal to kb plus ka. Okay? Now, let's find what CX is, okay, in terms of n. So CX, we should go from C to F up to X. Okay? So CX is also equal to again, negative a minus b, like this. Now plus fx. Okay, and we know that fx is going to be this, n over n plus 1. We've already calculated this. 2a minus b over 2. And then that's going to be plus b minus a. Okay. Now, this looks a little bit messy, so let's try and like tidy up with getting all the coefficients of a and all the coefficients of b. Okay. So, let's do, that's 2n over, I'm just expanding this out, n plus 1 a, and minus n over 2n plus 1 b, plus b minus a. So I'm subtracting 1 to the coefficient of a, so this is 2n over n plus 1 minus 1 a, and then plus coefficient of 1 minus this, so it's going to be 1 minus n over 2 bracket n plus 1 b. Okay, so let's make this a little bit easier to understand, so let's just get everything in terms of n. So 2n over n plus 1 minus n plus 1 over n plus 1 a plus 2n plus 1 over 2n plus 1 minus n over 2n plus 1 b. And this is going to be equal to n minus 1 over n plus 1 a plus, this is going to be 2n plus 2. I'm going to minus the n, so that's just n plus 2 over 2n plus 1 b. Okay, now we found what Cx is, and Cx is this. However, from earlier, we also know that Cx is this. So we could just match up the coefficients of this to the coefficients of this. Okay? And because it's just k and k, so n minus 1 over n plus 1 is going to be equal to k, and n plus 2 over 2 bracket n plus 1 closing bracket is also going to be equal to k. So we could just equate these two together. So what I mean by this is, let's do that. N minus 1 over n plus 1 is going to be equal to n plus 2 over 2 n plus 1. The reason I did this is, here the coefficients are the same. Okay, for Cx, the coefficients are the same. Okay, so here as well, when you calculated Cx using n, the coefficients of a and b also have to be the same. Okay, because remember, we're finding the same vector. So, it means n minus 1 over n plus 1 has to be the same as this. That's what I just wrote here. Now, let's rearrange the equation. So let's do 2 times n plus 1 on this side. So I've got n minus 1, n plus 1 is equal to n plus 2, n plus 1. If we expand this out, we get, this is a difference of 2 squared times 2, so 2n squared minus 2 is equal to n squared plus 3n plus 2. Okay? Now let's bring all the terms to one side. So let's subtract the n squared, subtract the 3n, subtract the 2. We get n squared minus 3n minus 4 is equal to 0. Now let's just factorize this. So let's think of two numbers that multiply to negative 4 and add to negative 3. Well, negative 4 and positive 1. And negative 4 and n plus positive 1 is equal to 0. So n can either be negative 1 or 4. But since n has to be positive, because of this, it's a what's it called, vector. So it's a scalar. So we know that n has to equal 4 is the only solution. So n equals 4.